Right on time. All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up number 21 is on the screen. Let's get started, please. By now, once again, numbers 1, 2, 3, and 4 should be a piece of cake. Yeah, 4. Why isn't the last one also 4? And number 5, which is the last one, I'm going to change that a little bit. The binomial theorem is practice of what we did the other day, so copy and go. All right, y'all ready? Today we have a packed session, so make sure you stay focused. It's going to go like super fast, like that. Did you see that, Anthony? That's pretty quick, huh? All right. Get us started, please, with number 1. Emily, what'd you get for number 1? You said negative? Okay, that would be correct if we were multiplying, but notice this one has a, frozen. Let it go, let it go. Have you guys heard that song before? All right. There's a negative in here in the middle, which means we distribute that negative. All right. So with that said, help her out. Maya A, what'd you get for number 1? -7. You said -7y? Okay. Plus x squared y minus 15. Like that? Okay. All right, let's double check. This becomes -7x squared y. This becomes -3, and this becomes -5y. So, let's see. 9x squared y minus 7x squared y, that should give us 2x squared y. So far so good, yes? Then we got 5y minus 5y. What is that? 0 pair. Then we got -12 and -3. That's -15. And have you got that? All right. Let's go to number 2. Let's see, we started with Emily, Maya. Jaden, what'd you get for number 2? 12x cubed plus 22. 22x squared plus 4x plus 4x minus 3. Hands, have you got that? That is correct. Go. Number 3. Trinity. Seven less than x less than or equal to 10. Hands, have you got that? That is correct. Woo-wee. Number 4, GCF. Let's see. Emily, Maya, Jaden, Trinity. Brandon, Felix, GCF for 40 and 24. Hands, have you got 8? That is correct. Man, that's like 4 in a row. Let's go. A little heavy? No. All right, and I'm going to go over number 5 one more time just to make sure we got the process. However, so here, what is the first thing we look at when we are given a binomial to whatever power? What's the first thing we look at? Everyone, the exponent. That's going to tell us to build our triangle to the 4th row. So we got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and I stop whenever I see 4, 1, 4, 6, 4, 1, and I stop right there. Next, I take these numbers, they become coefficients, yes, for each term. 1 space plus 4 space plus 6 space plus 4 space plus 1. From there, I start with my first term. What is my first term? 3x I put that in parentheses, to the fourth power. Then I go to the third power on the next term, 3x to the second power, and 3x to the first power, 3x to the 0 power. Okay? From there, I take the second term, and I start 2 to the 0. That one we started at 0. 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. All right? And if you got it to write that by yourself? Yeah, we got this, yes? All right, here we go. Bring down the 1 times 3x to the fourth power. That means 3 to the fourth power. That means 3 times 3 times 3 times 3. That should be 81. X to the fourth power times, what is 2 to the 0? 1. Plus, bring down the 4. 3 to the third power. 3 times 3 times 3, that's 27. X to the third times, what is 2 to the first? 2. Plus, bring down the 6 times 3 to the second power, that is 9x squared, times 2 squared, that is 4, plus, bring down the 4, times 3x to the first is 3x, times 2 to the third, 2 times 2 times 2, that is 8, plus 1 times, what is 3x to the 0? 1. 2 to the fourth power, that is 16. And so we got up to right there as well. Yeah, okay. And last, we just simplify it. I start by multiplying these numbers first. What is 1 times 1? 1 times 81. 81x to the fourth. Plus, what is 4 times 2? 8 times 27. $216, yeah. Bring down the x to the third, plus 6 times 4, 24, times 9, 216, x to the second, because you brought this one down, plus 4 times 8, 32 times 3, that's 96. Bring down the x. And last but not least, 1 times 1 times 16, that is 16. And if you got that by yourself, all right, we got this, yes? All right. We got this, oh yeah. Copy the agenda for today, warm-up number 21, factoring polynomials. We're moving on. Tonight's home plate play sheet Q is only numbers 1 through 10 only. And once again, reminder, tutoring after school, be there or be elsewhere. Huh? You guys haven't heard that term? Be there or be? No? Okay. I guess another generation. They used to say be there or be square. I don't know if you heard that before yet. But I say be there or be elsewhere. Get it? Like you're not there, so you're elsewhere. Yeah. All right. And by the way, tutoring is free. Let's go. Also, video lessons of the new concepts are always being uploaded on a daily, so make sure you go to the YouTube channel, subscribe, share. I already have 1,050 subs. Let's go. I'm getting there, almost to the 1,000,000. Little by little. God, I always keep wondering, like, I wonder why it takes longer for people to subscribe to mathematics than other channels. Oh, weird, huh? So you're like, because they don't like math, Mr. Q. Well, I get it. I get you. All right, we good? All right, so nearby code. Write this down for the home plate. 3SEB8. 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 And once again, if you have someone that's struggling with their math, just let them know the process of our daily, you know how it goes, you know, warm up, agenda, lesson, I tell people to stop, copy, and stuff like that. Because I have playlists. I have an Algebra 1, the entire course, it's in there, in videos. I have an Algebra 2 course as well, playlist. And I have a statistics course in there as well. So, let's go. And they're free. Can you believe that? Crazy. All right. So yesterday, act like tomatoes. Tonight's home play, only 10 problems. There they are. Yes? Beautiful. All right. All right, here we go. Get a Cornell note ready. You don't need a Fair model today. Our objective for today, I can factor polynomials. I can factor polynomials. I can factor polynomials. And once again, I mean, not to keep beating this point, but polynomials are here to stay, guys. They're like, you know, for somebody that don't like polynomials, they're kind of like that one person that's always getting there to your group late, and you guys are like, oh, here they come, man. You're like, oh, man, here they come, right? They're like, that hasn't happened to me. Well, maybe that's you. From the corner, let's go. Wow. Anyways, factor. The word factor means, write it on the side. Word factor in parentheses, write divide. Divide. That's another word that we use for division. So, factor means what? Divide. Divide. And today we're going to be doing that with polynomials. But before we move on, tell your neighbor the definition for polynomials. Experts by now. Tell your neighbor, definition for polynomials. All right. We got it? Yes? David, go. Monomials or sum or difference of monomials. Yes, that is correct. You got to change it to polynomials, but I helped them out right there. I got you. All right. So there they are. We know what they are. Have I been hammering this point? Yes? Okay. All right. So, write your utensils down. Look up to the screen. Let me pause the tunes in the back. Any questions with greatest common factors? Have we been practicing enough? All right. So here goes one more time. Ready? I need to get all the factors for 24 first. So I start with 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Yes? All right. This one is 1 times 18, 2 times 9, 3 times 6, and then they all repeat. Okay? So from those, we need to go with the greatest one. Which one is the greatest one for all? 6, this one, and this one. So my GCF is 6. Okay. Now, another way of doing this is like this. Look up. For those of us that are experts, is asking the question, what number divides 24 that also divides 18? So you're like, both can be divided by 1. Okay. How about 2? Yes, yes. How about 3? And just go down the list till you get, oh, it's 6. Okay. That's going a little bit fast. Now, why did I have you practice that? Because we're getting to this part. Here we go. I need all the factors of x cubed. How do I write that, Mr. Q? Let me show you. X times x times x. How do I write this one? 1 times 2 times x. Are we there? All right. Do they have anything in common? Anything else? No. So my GCF is x. Are we there? Okay. So, on your paper, copy this, example Q. Example Q. Don't copy these are too easy. Let's do, give me a number. 6 x to the fourth, and let's do 9x to the second. Okay, ready? Let's do number 6 first. Let's break it down into factors. Could it be divided by 1? By 2? By 3? Okay. Any of those gives me that, yes? I'm not going to use 6 because the 6 is itself. How do I break down the x to the fourth? X times x times x times x. Let's go to the next one. 9 can be divided by 1, yes? How about by 3? All right. So, x squared, x times x. All right. So, what do we have in common? A 3, a 1, what else? And 2 x's. My GCF is 3x to the second. Okay? All right? So, now to give some of us a system, because some of us are looking at it like, copy this, example, mega cube. Let's do 12y to the fifth and 8y to the seventh. Okay, before you continue, I'm going to make a factor tree for the 12. Ready? Here we go. Open 2 arrows like so. And I'm going to start with the number 1, just to make sure I get rid of number 1. Can 12 be divided by 1? Yes. What is 12 divided by 1? 12. Next, can 12 be divided by 2? That gives me 2 times what? 6. Next, can 6 be divided by 3? Yeah. Okay. 3 times 2. And that's it. Is that correct? These are called prime numbers, so we stop right there. How do we write this one? Y, 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 y. And I'm going to write this one, this one, this one, and this one, because these are known as prime. So I write 1 times 2 times 2 times 3. Do the same for 8. Can 8 be divided by 1? Yes. By 2. 8 divided by 2 is what? 4. And 4 could be divided by 2, and we're left with 2. So these are my what? My prime. So it's 1 times 2 times 2 times 2 times y, 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 and y. So, what do they have in common? Do we have a 1? Yes. Do we have a 2? Yes. Do we have another 2? Yes. What else do we have? How many y's do both have in common? 5 of them. Okay. So, my GCF is, what is 1 times 2 times 2? 4, and then y to the 5th power. How we doing? Another one? Yes, Mr. we love these. All right. Example Shazam cube. Write this down. Example Shazam cube. Let's do 14x to the third and 49x to the fifth. All right, let's start with 14. Could it be divided by 1? Yes, 1 times 14. Could it be divided by 2? Yes, 2 times 7. Is 7 a prime number? Can only be divided by 1 in itself? Yes, so we stop there. So my numbers are 1 times 2 times 7. And then what? X times X times X. All right. This one. 1 times 49. What divides 49, everyone? 7. 7 times 7. And we stop right there. So my factors are 1 times 7 times 7. And then we have x to the 5th. So, do both of them have a 1? Yes. What else? A 7. What else? 3 of those x's. So therefore, what is 1 times 7 times x times x times x? My GCF is 7x cubed. From 1 to 5, I'll come through you with GCF so far. 5, 5, 5. You coming back? Yes? All right. One last one. Example, super duper Michael Jordan cube. You're like, oh, snap cube. Oh, yeah, I got you. Here we go. 10x to the 3rd. Over here, let's do 8x to the 4th. And 15. No, let's change that to, my bad. Let's change that to 4x to the 2nd. So there's 3 different numbers, 3 different terms. Find me the GCF. All right, let's see. 1 times 10, 2 times 5, so that is 1 times 2 times 5 times x times x times x. So far so good, yes? 1 times 8, 2 times 4, 2 times 2, so that's 1 times 2 times 2 times 2 times x times x times x times x. This one, 1 times 4, 2 times 2, 1 times 2 times 2 times x times x. Therefore, do all of them have a 1? Yes. Do all have 1, 2 at least? Yes. How many x's do all of them have in common? 2, 2, 2. So that means 1 times 2 times x times x. My GCF for all of them is 2x squared. Hands, have you got that? All right. Now, is that the only way of doing this? No. Remember what I told you on the warm-up? Another way of thinking about it is this. What number divides 10, that divides 8, that divides 4? 1. How about 2? 2, 3, 4, 5. So that means I stop at what? 2. Look at the variables. X to the 3rd, x to the 4th. That means there's 4 x's in there. X to the 2nd. So the smallest one is 2. Do all of them at least have 2 of them? Yes. So my GCF is 2x squared. From 1 to 5, I'll come through you with this. Okay. So this is where I'm going. Check this out. We're about to embark in factoring polynomials, which is dividing polynomials. And we need to know this technique of GCF. Because look, if I was to write this as a polynomial, it would look like this. 10x cubed plus 8x to the 4th plus 4x squared. Does that look like a polynomial? Yes. But it's not in standard form. We would have to write it in standard form and then identify the GCF. Okay? So with that said, copy example number 1. Factor completely. Factor completely. 2x squared minus 3x. So this skill, guys, is basically something you already saw in Algebra 1, but I'm bringing it back because we're about to build up from there, but I'm just taking it slowly, step by step, so you guys can see the process. Here we go. So, to have a process, on the side, I want you to write number 1, S, F. We need to make sure it's what? Tell your neighbor. Standard form. That is correct. If you need to write it out, standard form. So look at it. Is it from highest to lowest degree? Yes. Step 2. G, C, F. From now on, this is the bread and butter of polynomials and factoring. Those 2 steps. Tell your neighbor the 2 steps again, please. Yes, make sure you know those 2 steps because this is the bread and butter after we get into the factoring portion. And at the end, step 3, factor, in parentheses, if possible. And number 4, simplify. All right, here we go. Standard form, check. GCF. All right, here we go. I'm going to go a little bit faster now. What number divides 2 that divides 3? 1. Okay, I'll write it 1. Does this term have an X? Does this one have an X? Do both have 2 X's in there? No, so it's only 1 X. So I open up parentheses. All right, so here we go. Since 2 is the same as 1 times 2, I already took out the 1, and I'm left with what? 2. How about x squared? It's what? X times x. We took out 1x, so we're left with x. Negative. The 3 is the same as what? 1 times 3. Is that correct? Well, what did we take out over here? It's a 1, so we're left with 3. Did we take out an x already? Yes, so therefore, these are my factors. How many of them? 2. 1, 2. 2 factors. Are we doing from 1 to 5? How comfortable are you with this so far? Yeah, 5 fourths, 5 fourths. Let's do another one. Copy this. Example 1 cubed. 6y squared plus 18y. 6y squared plus 18y. All right. Here we go. What number divides 6 that divides 18? 1. How about 2? Yes. How about 3? Yes. How about 4? 5? 6? Yes. So let's write 6. Okay. Do both of them have at least 1 y? Yes. All right. So 6 divided by 6 is 1, so we're left with 1. We took out 1 y, so we're left with y. Plus, what is 18 divided by 6? 3, and the y we already took it out. So these are my what? Factors. This one and that one. How many factors? 2. All right. How are we doing? Yeah? All right. Example 1, Michael Jordan cube. Let me give you one more. Let's do 8 q to the 5th plus 20 q to the third. Find me the factors, please. All right. Let's see, what's the biggest number that divides 8, that divides 20 as well? I heard 4. Yes, 4. How many q's does each term have at least? 3. So we write q to the third. So, what is 8 divided by 4? 2. We took 3 of these q's out, so we're left with q to the second. Plus, what is 20 divided by 4? 5, and q to the third, we already took it out, and we are done. These are my factors. How many factors? 2 of them, that one and that one. From 1 to 5, how comfortable are you with that so far? Okay. I think we got this, yeah? All right. How about we crank it up a bit, yeah? Oh, yeah. Copy this one. Example 1, super cute. Negative 3m minus 3m squared plus 3. Negative 3m minus 3m squared plus 3. All right, before you get going, some of you already wanted to get going. So you remember the very first step you're going to check for. First thing you're going to check for. First thing we check for, Maya G. Very good. She said standard form. Standard form. Is it in standard form, people? No. First degree, second degree, 0 degree. So let's rewrite it. Negative 3m squared minus 3m plus 3. Now it's in standard form. What's the second thing we check for, everyone? GCF. So what number divides 3 that divides 3 that divides 3? 1 and 3, but the greatest one is 3. Now check this out. Since the leading coefficient, the very first number is a negative, we're going to make our GCF starting at negative 3. Negative 3. Once again, remember that. If the leading coefficient has a negative, make sure you put that on the front. Does each term have an m? No, just these two. So guess what? My GCF is negative 3, which means, let's see, what does that leave us at the end? What is negative 3 divided by negative 3? 1m squared. Next, what is negative 3 divided by negative 3? Positive 1m. And what is 3 divided by negative 3? Negative 1. And these are my factors. Factors. How many of them? 1, 2. 2 factors. All right, from 1 to 5, how comfortable are you to right there? Yeah, 5, 4 is 5, 4, 23. I get that. Okay. So, that's part of the home plate. But this is where I'm going. Notice that there's a little pattern going. Yeah. But we're still doing what? Division. But we don't call it division. We call it what? Factor. Mr. Q, why do you call these factors instead of just saying factor? Because there's 2 of them, and whenever you have 2 or more that are multiplying each other, they're known as factors, okay? Now check this out. We're going now to this next part. Before I go to the next problem, which is similar to the one we just did, I'm going to give you this one, factor. And let's label this one Star Wars Q. Star Wars Q. Ready? Write this down. X squared plus 5x plus 6. Do the first 2 steps together. Is it in standard form? Yes. Is there a GCF? Let's see. Is there a number that divides this one, and this one aside from 1? No. Do all 3 terms have an X? No. Okay. So, writing utensils down, look up to the screen. Now, when you are given a polynomial like this, this is a what? A trinomial, yes, and it's a quadratic because the highest degree is 2, okay? When you're given a trinomial like this, there's a pattern on how to find the 2 factors that make this trinomial. However, instead of just thinking it out, there's a process. I call this process, I don't know if you guys grew up with the Power Rangers. You guys, go Power Rangers. Yeah? So right away, I do this. Probably seen this before, hopefully. Okay, check this out. I'm going to write, I'm going to write this number on top, this number on the bottom, and I'm going to think, what two numbers multiply to give me 6, so that those two same numbers add up to 5. Tell your neighbor the two numbers that multiply to give me 6, that when you add them, give us 5. All right, who's got them? Let's go. 2 and 3. 2 times 3 is what? 6. 2 plus 3 is 5. Copy that really quick. All right. Next, look up, please. Look up, look up, look up. This next step requires for us to do factoring by grouping. I can do a shortcut, but I don't want to do the shortcut just yet. Here it goes. First thing I do, I bring down the first term. I bring down the last term. Pay attention to this part. And then this 5 can be written as 2 plus what? 3. So I would write 2x plus 3x. Does this give me that? Yes? Copy that really quick. Now that we have 4 terms, this is what we call factor by grouping. I'm going to group 2 terms together and then another 2 terms. So, look up. Question. What would be my GCF for these two? 1 and 1x, right? So I'll just write 1x. All right. So if we took 1x out, we're left with x plus 2. Plus. What's the GCF for these two? What number divides these two terms? 3. Okay, so I'll write it out here, 3. So 3 divided by 3 is 1, and that leaves us with 1x plus 6 divided by 3 is 2. Are we there so far? All right. You're like, it's kind of long. I know, I get it. Here we go. Question. What's the same here and here? X plus 2. That's my first factor. X plus 2. And last but not least, what's left if I take out the x plus 2 from the red? 1x. What's left here if I took out the x plus 2? Plus 3. So my second factor is x plus 3. These are my factors. Let's do another one. Example, Teenage Mutant Ninja Turtles cube. Here we go. X squared plus 7x plus 10. Follow that same process. Go. Once again, hopefully for tonight is on that code you got earlier, tutoring after school, be there or be elsewhere. See you guys tomorrow. Bye.